Hi,
Hi.
how's it going?
Hello. Great. How are you?
Pretty good, yeah.
Right. I appreciate you taking your time to come and meet with us. We were really interested about your research with robotics and AI, and we just want to kind of learn more about your work. Do you mind if I record this to share it with other people who are interested?
Yeah, sure, sure.
Okay, great. What could I address you by?
I'm Priya. You can just call me Priya.
Priya. Okay. Okay. What year of your PhD are you into right now?
Yeah, so I am gonna start my fourth year next year.
Okay. Nice. Congratulations. Uh,
Thank
almost a
you.
doctor. Almost.
Yeah, exactly. That's the hope.
Right. Okay. So maybe we can get started here a little bit. Um, do you think you could maybe like give me a li or give us like a little bit of a overview about yourself and your journey in computer science and robotics, kind of?
Yeah, for sure. So I did my undergrad at Berkeley. I'm from California originally, so I ended up going to Berkeley for college. And kind of when I started college, I wasn't really sure exactly like what I wanted to major in. I initially was came in as like a bioengineering major actually, and I was potentially interested in doing some sort of like prosthetic type stuff. But I didn't really know like what I wanted to do.
Sure.
Um, and then when I started taking like a couple courses and at least like at Berkeley, BioE was like pretty broad. So they had us take like a few intro CS classes as well. And then I hadn't really done any CS in high school, so it was all very new to me. But yeah, I really like enjoyed the classes. Like I feel like um the other classes that I liked were like some of the intro like electrical engineering classes, so like circuit stuff. Um and so kind of like my freshman year, I was just taking a lot of classes, and then sophomore year of college, I decided like it would be kind of fun to try research, and I wanted to try out like doing more CS oriented research. Like at this point, I was kind of on the fence of just like switching from bio E to CS. So like I just reached out to a bunch of different professors like in the CS department at Berkeley, and luckily, like one of the professors who was working on robotics like got back to me and mentioned that he had like some openings in his lab. So yeah, from there I like kind of just ended up joining a robotics lab. Um, and they were working on like really cool stuff. I thought like I had no background in like
Right.
robotics or it was very like early on and even like CS for me. So but they had like a lot of robots that were they were trying to do like household stuff with like laundry folding or like
Sure.
tasks kind of like that. They also had like a surgical robot, and I thought like the applications of this stuff were cool. Yeah, so I just ended up like kind of just joining that lab and working on a few different projects advised by some of the grad students in that lab. And then I ended up like really liking research and the other grad students. So that's kind of why I decided to like go in down the route of a PhD. Um, yeah, so that's kind of like high level.
Sure. Right. Would you say like there was maybe like a specific moment that really sparked your interest in this, or would you say it was like more gradual? Because you know, you mentioned the switch from bioengineering to computer science. Was there maybe something that really sparked that, or no?
Yeah. Um, I think like so initially sort of like the stuff that I was interested in coming into college was like more on the prosthetic side of things. And I feel like when I joined this robotics lab, I felt like there's a lot of parallels between even just like like in building if you want to work on prosthetics, like there's a lot of like yeah, similarities to robotics. And I
Right.
was more interested in like I kind of realized through that like um I wanted to have like a way to do some more like hands-on, maybe mechy even type stuff.
Sure.
But like I feel like robotics was sort of just like this happy medium where you could like work on more of the hardware stuff if you wanted to. There's also like I think when I joined the lab, I saw like a lot of projects that were using the surgical robot. Like I don't know if you've
Okay, yeah.
seen like the
Yeah, yeah,
intuitive.
yeah, yeah.
Yeah, yeah. And like we had like some students in the lab who would even just like teleoperate the robot to like do some tasks like, like picking up fruit, like peeling like grapes, like stuff like that. I think
Sure.
that was I realized like that's really exciting and uh yeah, I kind of thought like robotics was like a good sweet spot for like
Sure.
many of the interests I had.
Right.
I think that's kind of when I just decided like it seems
Right.
like a good
So joining the lab was a key factor in you kind of like figuring out that maybe you weren't like 100% in bio or 100% bioengineering or mechie, but it was like kind of a sweet spot for you.
Yeah, exactly.
Sure.
Um, yeah, I would say like I think being in the lab really helped because through classes I felt like it was a lot less hands-on.
Sure.
Um, like I would learn about like cool concepts like computer vision and stuff in like the classes I was taking, but I felt like until I could actually apply it to something, like it didn't really click. So yeah, I would say
Right.
that kind of like made a difference.
Right. The application that you got from being in the lab is different, right? That's pretty cool.
Hmm.
So, what one of the things that we were interested in was a lot of your research was, really, really fascinating. It was kind of combining the like human side of things and the robotic side of things, to achieve some human tasks with robotics. One of the things we were interested in was if would you be able to like maybe give us a simple overview of some of your recent research? I know one of the papers that I saw recently was the flare paper that you worked on. Um, I'm not sure if that's a paper that you'd like to discuss or, another paper that you're interested in, anything that you think is interesting you'd like to talk about.
Sure, yeah. I can give a brief overview of like maybe Flare. Let me just pull up the website. 1 second. Um, okay, let me share my screen too. So, okay, I think it'll load in a second. Yeah,
Yeah,
so kind of like the motivation for this project is that so in our lab at Stanford, my advisor who's Dorsa, she she had got me interested in this application when I joined, but um, one, I think like one thing that robots have the potential to help a lot with is like these kinds of assistive settings where, for example, there's a lot of people with mobility limitations who currently like need a caregiver in order to assist them with like a lot of
sure,
activities in daily life. Like feeding is one of the biggest ones that caregivers are a huge help with currently. But we're interested in whether we can get robots to be able to help with this kind of thing because it's also very tedious for a caregiver to have to do.
sure,
And it can be like kind of like from a lot of people with mobility limitations we've talked to, like especially like imagine like when you go out for food with your friends or like things like this, like it's a very social thing and you don't
right,
necessarily want one person feeding you.
right,
Um, and many of these people also like currently already have like some people have wheelchairs that have like a robot arm on the side. Um, and the way that they usually use it in their daily life is like by having like a little joystick that they can use to like pick up things around their house, open fridges,
sure.
stuff like that. So yeah, we're kind of interested in like if this is the setting we're in where like someone has access to a robot, can we get them to autonomously do more useful things like feeding? Um, and so Flare was basically like a system that we recently worked on, trying to work towards this problem of like how can robots autonomously feed people. I would say like this is just kind of like a step towards this. Like this is still a really difficult problem, and you'll see lots of failure videos in this. But yeah, like I think it's an exciting application as well because it's like a very real use case and
Sure. Hmm. Like a first step in this kind of domain, right?
yeah,
Right.
exactly.
I think
Um,
that's, mhm.
yeah. And so like
Yeah,
basically the idea was just to like use like a lot of foundation models, which have now gotten really good at, summarizing people's preferences and also detecting objects from images and combining them with like the system to be able to feed plates in a way that like can deal with preferences people could have. Um,
Sure. Yeah.
example.
I mean, those examples are kind of mind-blowing right now. Like that arm. So that arm is not being controlled, right? You just gave it the prompt and it's doing all that by itself.
Right, yeah. So we kind of like the system has a set of skills. So these are some examples, and they are all like based on vision inputs. So we have like a camera on the robot wrist, and it can sort of like see the plate and also sense like RGB, but also depth. So
Right.
when we combine like a object detector with these like raw images we get, we can sort of like estimate the pose of these food items and then plan these kinds of skills. So yeah, these are some autonomous rollouts of that, but like you mentioned, like these are not hard coded in any way.
Right. No, that's
Mhm.
amazing. That's really fascinating. I mean, I think I don't know. I just think that that's really cool that there's so many different things that have to be working in parallel for that to happen. Like it needs to know how to move freely, it needs to know how to do all those things. I just think that, the fact that we're at a state in current computing that that can happen is it's kind of amazing. I think that's really cool work. So maybe some questions about that work there. I was wondering, could you maybe talk to, you know, what are some key challenges that you faced in that research?
Yeah. So I would say like from a technical standpoint, like some of the biggest issues in the current system are still with like the robot's low level control. So like a lot of especially food, it comes in like so many different varieties and
Right,
being able to handle all of these is like definitely still an open problem. For example, like the way that we implement all of these like food pickup skills is very open loop right now. So for example, when you're like twirling spaghetti or something like that, the robot is not sensing like how much has already been twirled. So we run into these cases where sometimes like you pick up too much food, too little food. Um, and so that is still a pretty big failure mode of the system. Another challenge is like as you saw in like the videos, most of these plates are like just like a flat plate with some food on it. And things become very difficult when you move to something like a curved bowl with like lots of food that could be also like stacked on top of each other and including parts of maybe food items you want to pick up.
right,
So I would say trying to generalize to all these different cases is still an open challenge. Um, so right now we're kind of interested in moving towards like, can we learn like robot policies that are more reactive? So like imagine like if a human can give demonstrations of like, this is how I pick up food in like these scenarios, and then maybe learn from human videos or from like some data that we're able to have by putting sensors on utensils people use. That's definitely something that we're interested in. And then beyond like just like the technical challenges, I would say that a big challenge in like a lot of robotics research is it's difficult to know like whatever algorithm you develop in the lab, you really don't know how well it does in like the real world.
sure,
um,
sure,
and especially like this kind of artistic research. People like with mobility limitations can have very different um like backgrounds. So like some people, for example, like maybe they already do have a little bit of like sensation and movement in their hands that they just need like help with like maybe the final stage of like
right.
or like
Like the twirl or something. Like,
yeah, exactly. And so I think trying to personalize these systems, but also like have them scale is like an open challenge for sure.
right. I think one thing that
Mhm.
was really interesting that you said there was the idea of like kind of tracking or analyzing how humans do it, like with sensors on a human. I think that's a really interesting idea. How is the data that you guys are currently working with? Like, how is that structured? Is that also like following humans or are there like is the system learning from a human, or is it more like, you tell the system what it can do, and like reinforcement learning, kind of like giving it props if it does it the right thing, or how
Mhm.
is it trained right now?
Currently, we don't even really have any like learning in the emotions itself. Like we have some uh primitives that are basically like it's sort of like a template of like for a skill like skewering, like you want to go above the food item, go down, and then skew.
Sure. Okay. 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 Mhm.
Like these templates are parameterized by like what angle should the fork be with respect to the food item, and we can try to sense those things from vision first, and then pass that as like input to these kinds of commands. But what you suggested is definitely like up there in terms of things we want to try. So I think in the future, like especially if we want to learn more reactive motions, like we need to start incorporating probably something like imitation learning, where a human is using some sort of utensil that has sensors on it to record examples of this, and then we record like what the trajectory was, what were the vision observations, maybe even haptic data, which you can imagine would be very important for something like food,
Right.
and then into like a neural network that can output actions. Um, we have also thought about trying to do things in a more like self-supervised way. So like I guess like RL reinforcement learning is like a way that the robot can learn from its own experiences by trial and error. But a challenge there with food is that like as the robot is playing with food, imagine it gets damaged.
Oh yeah. Yeah.
Um,
Yeah.
and like it's also hard to reset the scene. So
Sure.
I think this is like kind of one of the reasons we're in the future trying to go down more like learning from demonstrations rather than RL.
Right. I think that's definitely one of those real world challenges that you can't really get around. You like the food isn't
Yeah,
gonna fix itself. It's not like gonna reset like in a simulation type thing.
exactly. Yeah.
Yeah, that's definitely interesting. I think that's one of the issues that you might run into with robotics, in comparison to another field, like another AI type field, or because it's like real world. It's like the manifestation is right there, so it
Yeah.
provides some new challenges. So I think, yeah.
Mhm.
Maybe you could speak to, I know you touched on it a lot about how like this is the first step in a couple in the future of assistive technology for especially caretakers and delivering food. But maybe you could like go more in depth on some of your more significant findings in the research.
Yeah. So I guess like regarding uh findings, like most of these projects that we work on in the lab are either like we measure success rate with respect to like some baseline policies. So like in general, like with every new project, we want to have a sense of like how well does it compare to like what the current state of the art is and like what are still open challenges um, from like just the standpoint of like how good is your system currently. And then another aspect that is important in this kind of research, especially like anything dealing with assistive technology, is user studies to figure out like if you bring in real users, have them try out the system, what is their opinion on it,
Right.
how well they perceive it to work, how well does it like follow what their preferences are, and also behave in a way that would be like actually like they would want to use it or not.
Sure.
um,
Right.
so like for example, in this work like with feeding, and I would say this applies more broadly to different robotics tasks. Like one of the considerations or like metrics we consider is, how fast is the robot able to feed? Because in general, like if you look at like videos of industrial robots that are like doing stuff in warehouses, like they can move at super high speeds and do like
Right.
really crazy.
Right.
Um, in this case, it's like we need a lot of nuance because like you can't have a robot moving so fast when it's in
Sure.
such close proximity, but it's also like for in order to be useful, like the system can't just be feeding at like a snail pace.
Sure.
Like
Sure.
it'd be really awkward for a person trying to enjoy their meal. So
Right. Right.
we like kind of consider in this case comparing so flares like our approach and we compare against like a baseline which only tries to focus on picking up food as fast as possible. And we also compare against an approach that is like always trying to follow the user's preference. So, for example, like in this case, like if the plate of food has like not very much variety, we want like our approach to sort of like balance out like picking up like sausage versus mashed potatoes. And a efficiency only approach kind of starts by like picking up all the sausage first and then like all the
Oh,
mashed
sure.
potatoes.
Hmm.
So like this is fast, but it's not very natural.
Right.
Um, and then like I guess preference only, this is a bit of a misnomer because this is like a case where the user doesn't have a preference, but it prioritizes like trying to alternate. And what that does is like it wastes a lot of actions with like pushing away sausage in order to get
Hmm.
to mashed potatoes. Um, so we see that like our approach is able to be pretty efficient, but like still, you can see for like many different preferences, it sort of like has a higher perceived rating from users compared. Um, so this is like these are some of the metrics which we consider. And then I would say honestly for this work, we haven't done like a super thorough user study yet. We did this demonstration with a user who has multiple sclerosis, but we haven't really been able to test this super widely yet because honestly, like one of the challenges I feel like as a grad student is just like trying to recruit enough people.
Sure. Yeah, getting people to agree to this might be a little challenging too. Right? I mean, it's kind of, I mean, I bet in a couple of years it might not be too foreign, but at least right now, I'm not sure that people are exactly very used to, I mean, this kind of technology, right?
Yeah,
So,
exactly. And also like I would say like the findings that we care about are like how do people with mobility limitations like perceive these systems and trying to like recruit that population that's able like you're saying like willing to
right,
test. That's a process. And even like if we have like we do test it like with like I feed myself in order to like see how the system's working,
right,
like
right.
like that, but like you don't really know how that like those findings on people without mobility limitations aren't always the most informative. So
Sure.
yeah.
Okay. Yeah, I mean, I think that's a lot of insight on the project. I think I think that it's really interesting. But I do want to take maybe one step back from the project and talk about more just like human robot interaction. I think that I did have some questions just general for you about it. So maybe one question that I have here is like, how do you envision, right? I know you're at the forefront of this, right? Working with robots and people all the time. So how do you envision like the future of like human robot interaction, particularly in like a household setting, like going forward in the next 5 to 10 years?
Yeah. So I think like in general, there is like a growing like trend even in academic research to try to focus on like real world deployment
Mhm.
and getting robots to work in settings outside of a lab, like actual homes and things like that. Um, and I think one of the biggest issues right now is just like in the real world, we have so many random things that happen in our environment, in our day that like are not ever going to be seen in like data collected in a lab, for example.
Sure. Hmm.
I do think in the next at least 5 to 10 years, there's going to be a bigger push towards like involving people who are not even like roboticists in any way, just people who are, going about their day to help with collecting more data to
Sure.
that can be. So, for example, there's been a lot of recent systems that focus on like getting people to be able to like wear like a camera on your chest or something while you are doing everyday activities, or maybe even like using like an Apple Vision Pro or some kind of like headsets
Hmm.
and just continue your daily activities and this way be able to collect a lot of data.
Right.
Um, so I think like that's one way that humans will be very involved in the future. I do still think that like right now robots are quite a ways away from like
Sure. Hmm.
be, be deployed at low cost and help with like lots of activities. So I think it'll be a much more gradual process.
Sure.
But
Mhm.
yeah.
Yeah, I mean, I think you're right. I think some of the nuances that we talk about with like how, when you think of like a LLM or something like ChatGPT, where it's like I wouldn't say it's at its final stages, but you can already see like a product kind of coming out of it, and it's like really adaptable. So when we think of like improvements, they're kind of small scale improvements. One of my questions I had here was, how do you think we can effectively like teach robots to navigate and understand like nuances of human norms and maybe even cultural differences? But I think that kind of question, like the answer to that, you might not even know where to start right now because we haven't even, it like the robots haven't really been put in a situation where they had to try and get around cultural differences right now because they're still in academic settings most of the times. Would you say that that's correct?
Yeah, I definitely agree. I think like you mentioned, like this is a very relevant question for especially like when we want to deploy robots and how they should be able to follow social cues, like do social navigation, these kinds of things. Um, and I do think to your point that like vision language models and language models are moving at like a much faster uh, development and deployment cycle than robotics is. So I do think like we can use all of those things to our advantage in robotics. Like a lot of the reasoning aspect of deployment of like perceiving your environment and seeing like, oh, like there's spilled milk in the kitchen, so I should like go there and clean it up. Like this kind of like high level reasoning, I do think we can benefit a lot from like existing vision and language foundation models. And even like cultural things like maybe knowing when not to enter a room or like
Right.
uh,
Hmm.
say when you see someone is like taking an exam in a room, like go around to a different room,
Right.
stuff like
Right.
I think those kinds of like reasoning, like language models are actually, I would say, already really good at that kind of stuff. But
Mhm.
still, the hard part is just like the actual, like, how should like the robot motors move and like get around places and robots I feel like are still so clumsy. And
Sure. Right.
I would say like another challenge that I think like hasn't been so straightforward in robotics compared to some domains like vision and language is that like in language we have a very clear um like it's a very easy to work with data format, whereas for robots, like we
Sure.
don't even really
Mhm.
know what is the right embodiment.
Right.
So, like there's so much hype recently about like humanoids because maybe like the sort of like I guess idea is that like the world is designed for people, like even the heights of tables and like microwaves and cabinets, like those these are things that like are designed for people, and so therefore a lot of people think we should have like a robot embodiment that's human-like, but humans are also super suboptimal. Like it takes us so much practice to walk downstairs and like do things like this that like dogs are so much better at, for example. So
Right.
I think like the bigger challenge, like at least right now, is just like figuring out what embodiments actually are good for deployment before we can move to these like higher level reasoning kind of things. Yeah.
Right. And I think that sometimes some of the issue is even further than just what you mentioned. Maybe even like some people, like the public. I don't know if this is true in here a lot, but sometimes people talk about this like uncanny valley type idea, where like the more human a robot looks, the more like icky feeling you get, kind of. So I mean, I don't know, maybe that's another thing to think about when we think about deploying like humanoids in the public. So
Yeah.
yeah, I think two or three more questions here. So there's a lot of talk, I know we were just talking about like NLP and LLMs. So one of the questions I had was, what role do you see like natural language processing or LLMs playing in developing more advanced robotics models in the future? I know you touch on that. I mean, robots don't really have a an easy to use like only language type data that you could easily interface the LLMs with. But just like in general, like something that was came to mind for me was you talk about efficiency for your Flare model. Like I'm not exactly sure how that's determined, but I mean, for my position right now, I would assume that that might be related to some sort of NLP. I'm not,
Mhm.
but I'm not sure. Maybe if you want to address that.
Yeah, yeah. Yeah, that's a great point. So I think like an example of I would say like with robotics, like one big challenge is like how can we get robots to perform actions that are useful over a very long period of time? And long is relative. Like what might be long for like you or like is probably like extremely long for a robot, and what
Right,
might be short for us is like long for a robot. So like for example, like if you think about um making food, like making dinner, that is usually like something that humans can do in like 30 minutes, like but it
right,
involves lots of steps, right? Like if you're making like following recipes, for example, can have almost like 10, 15 steps. Um and feeding is like a similar type of thing where it's like long horizon in the sense that you're feeding multiple bites to a person. Um, so I think one role that I see LLMs being very useful for is like figuring out sequences of actions for these long
sure.
horizon
Hmm.
tasks.
Hmm.
I think like LLMs have had great success, and if you ask it like, I want to clean up my kitchen, being like coming up with more structured plans that are like go to the sink, pick up a dirty dish, wash it, put it away. These kinds of things, like a robot, you don't want to have to train a robot necessarily to do an entire task from start to finish. That's so
Right,
nuanced. I think it's like much more scalable to think about like how can we train smaller behaviors like pick up an object, place an object, go to a location, which are like more general skills, and then figure out how LLMs can sequence them to do like these
right.
pretty cool things.
And
Um,
I think that like in a sense also talks to your idea of how there's a lack of structured data for robotics and maybe LLMs in that sense would help towards providing a more structured data.
yeah, exactly. Like, um, yeah, like we have like a lot of this data already available of like what just based on text, like what as
Sure.
a plan. So I think that's one aspect LLMs can help a lot with. And then the other thing is like kind of I think LLMs are good at describing like common sense things that like,
Right.
if you want to pour water into if you want to like if you want a glass of water, an LLM can tell you like you should look for this object and go find like a pitcher and then fill it up with water at the sink and then like pour it into a glass. Like
Right.
I think going from high level task specifications to like more grounded things like objects that you can then detect or track, that's something that LLMs are great at. So I see their role more as being like for these high level things that the robot should be that it doesn't have context about like natively.
Sure. I think that that's kind of like I'm not sure if that this is true or not, but I feel like that's kind of the direction that I don't know, like technology now is moving in, where like we have all these like different advances with LLMs. I know there's some recent advances with like new types of sensors and all these different things in robotics, and they all like culminate together kind of. So there's not like, the robotics is in charge of doing everything, but it can be like offloaded into these new advancements that are happening everywhere. So
Mm-hmm. I totally agree.
yeah, that's definitely true. So I think that's all the question. Actually, one more question I had. So from your perspective, right, as a PhD student going through all the process right now, I was wondering if you would have like if you had any advice for like I guess high schoolers, early undergrad students who are interested in pursuing a career in like AI and robotics.
Yeah, for sure. I would say like definitely just like reaching out to people about like regardless of where you go to school, reaching out to like find out how can you get involved with
Right,
um robotics in like research labs is like a great way to get started. I think like a lot of like the good news in robotics is that a lot of problems are not solved. So
right,
there's a lot of labs are always looking for students. There's also like summer programs that different schools host for like people who maybe are just trying to figure out if they're even interested.
Right.
So once you go to college and are looking like you can look at different schools and what they're like they often have like URAP or like these kind of undergrad research programs. Um, and I think it's like really like robotics I found has been like a very welcoming space. Like I think, coming from as someone who didn't have any background, like I think it's like one of those fields where you can just learn things as you go. And like even me having been in the PhD for a few years now, like there's so much about robotics I still don't know and like things that I'm constantly trying to like ask other people in my lab, have you tried this? Like, do you have any recommendations? I feel like it's such a broad field that like
Sure.
it's kind of inviting in the sense that everyone is feeling this
Sure.
overwhelming
Yeah. Yeah.
gap
Right.
and just tapping into what different people have experience with is great. And then I would say like, there's ways even to get started with stuff with like robotics without even having access to hardware. Like, I do feel like recently a lot of people have made a lot of efforts towards just like building good simulators to try stuff out in, and that can be a really good way to just like experiment with things even when, you don't have access to necessarily like thousands of dollars worth of hardware. Like you don't need that to try stuff out. And yeah, honestly, like I feel like all the high schoolers I talk to now compared to when I was a high schooler are already so much more like, plugged into a lot of these.
Sure. Yeah.
It's
Yeah.
cool to see that. So I say like, just keep pursuing things and yeah, reach out to people. And like I would say like a lot of people are willing to talk about their research, even if you're not asking for an opportunity or something like that, just asking like other grad students in general, I found have been super helpful, even like when I had questions about things, just asking about like whether to consider like going into industry later or like going to grad school, those kinds of things. Like I think just talking to people are like more than willing to help usually.
Okay, for sure. Yeah. I think thank you so much for your time. I really appreciate it. I mean, it was a great opportunity to learn about your research. And yeah, if you had no more questions for us, Priya, I think that should be about it.
Awesome. Yeah. Thanks for having me. This is like
Yeah, for sure.
first time done something like this, so it's really cool
Right.
to see you guys are
No,
doing
we,
this.
we thought your research was really fascinating, so we just want to learn more. So yeah, I appreciate you for coming in.
Oh yeah, no worries. Thank you so much.
Thank you. Yeah, have a great day. Bye bye.